Out there in the wilderness, the rules were brutal: build shelter or die. The frontier was merciless. If a man wanted to survive, he needed more than courage. He needed the forgotten knowledge of those who came before him, knowledge that could mean the difference between life and death when the elements turned savage. He needed shelters that could be built from nothing but what the land provided. Every technique mattered. One wrong choice, one forgotten method, and a man could freeze, drown, or find himself exposed to predators with nowhere to hide. Winter didn't care if you knew modern camping. Swamps didn't care if you had the latest gear. Storms didn't care if you followed the survival manual. The men who lasted knew the old ways. They knew the shelters that time forgot. What shelters did ancient peoples build that could save your life in terrain where modern techniques fail? Today we're exploring 7 forgotten survival shelters that kept our ancestors alive in the harshest conditions, techniques so effective they could save your life when everything else fails. My name is Sam, and this is Wild America. Number 1. The Half-Cave Shelter. The half-cave shelter was America's first lean-to. Long before European settlers arrived, Native American tribes across the continent had mastered the art of turning natural rock formations into life-saving refuges. This wasn't just camping, this was survival architecture that kept people alive for thousands of years. The technique was deceptively simple, but devastatingly effective. Overhanging cliffs, formed by the natural weathering of bluestone and limestone, created ready-made shelters that required minimal modification. The horizontal seams in these rock faces would split and fall away over centuries, aided by ice, rain, and the persistent roots of black birch and rock oak, until nature itself had quarried out spaces large enough to shelter a stooping man. But the real genius wasn't in finding these formations. It was in completing them. The original Americans would rest poles at an angle against the cliff face, creating a slanted wall that closed off the open side of the cave. Over these poles, they would layer balsam, pine, hemlock, or palmetto branches, always with the tips pointing downward to shed rain rather than collect it. This simple modification transformed a partial shelter into a weatherproof refuge. Archaeological evidence tells the story of just how effective these shelters were. Dig into the floor of any half-cave shelter in Pennsylvania or throughout the eastern states, and you'll unearth centuries of human habitation: pottery shards, mussel shells, bone awls, flint arrowheads, split bones from large game animals, and the charred wood of countless campfires. The Iroquois used these shelters so extensively that some sites show continuous occupation spanning generations. The half-cave shelter worked because it solved the fundamental problem of wilderness survival: maximum protection with minimum effort. In an emergency situation, a man could have weatherproof shelter in under an hour, using nothing but materials found within a few hundred yards of the site. No tools required beyond a sharp stick or stone. No complex engineering, just the wisdom to recognize what nature had already provided and the knowledge to complete what she had started. The projecting ledges form half-caves from the falling apart of the lower layers of the cliff, large enough to shelter a stooping man. This wasn't primitive camping. This was survival science that kept entire cultures alive through the harshest winters the continent could deliver. Number 2. The Barabara. Along the brutal coastlines of the Bering Sea, where winds could kill a man in minutes and winter temperatures dropped to levels that would freeze exposed flesh in seconds, the Aleut people developed what might be the most sophisticated survival shelter ever created: the Barabara. This wasn't just a house, it was a masterpiece of Arctic engineering that could keep families alive through months of conditions that would destroy any modern structure. The Barabara was built like an underground fortress. Construction began with 8 short posts for the outer wall, planted about 3 feet above ground, and 6 to 8 longer posts for interior support. The tops of these posts were cut wedge-shaped to fit precisely into notched crossbeams. This wasn't random construction. Every joint was engineered to lock together under the immense weight of the structure above. The real genius was in the shape. When viewed from above, the completed frame formed a hexagon like a boy's kite, with the front wider than the back. This design wasn't aesthetic, it was aerodynamic. The shape deflected the savage Arctic winds that could tear apart conventional shelters. The crosslogs were notched like those of a log cabin, but instead of building up, they built in, creating a dome-like structure that grew stronger under pressure. But the most critical feature was the entrance. Instead of a simple doorway that would let in deadly cold air, the Barabara featured a long, low tunnel entrance that forced anyone entering to crawl. This wasn't inconvenience, it was thermal engineering. Cold air, being heavier than warm air, would settle in the tunnel while the warm air remained trapped in the living space above. The entrance acted as a natural airlock, maintaining the interior temperature even in the most extreme conditions. The entire structure was then covered with splits, shakes, or whatever materials were available: birch bark, spruce bark, even sod and earth. The thick covering, sometimes over a foot deep, provided insulation that could maintain livable temperatures inside even when the outside air was cold enough to kill. For ventilation, a single hole in the roof served as both chimney and air exchange, carefully sized to prevent heat loss while allowing smoke to escape. This system was so effective that families could survive entire Arctic winters in comfort, with interior temperatures remaining above freezing even when outside temperatures dropped to 40 below zero. The Barabara represents the pinnacle of survival architecture, a shelter so perfectly adapted to its environment that it could sustain human life in conditions where exposure meant death in minutes. Number 3. The Bog Ken. In the treacherous marshlands and swamps where solid ground was a myth and every step could mean sinking into bottomless mud, early American settlers developed a shelter that defied the laws of physics: the Bog Ken. This elevated refuge solved a problem that stumped even experienced woodsmen: how to build a stable shelter on ground that couldn't support the weight of a man, let alone a structure. The Bog Ken was engineering genius born from desperation. The foundation wasn't built on the ground, it was built above it, using a principle borrowed from snowshoes. The builders would first create a thick mattress of twigs and branches, carefully layered in alternating directions, like a massive woven mat. This mattress distributed the weight of the entire structure across a wide surface area, preventing it from sinking into the soft marsh below. The construction technique was precise and unforgiving. The first course of sticks was laid in one direction, then the next course at perfect right angles to the first, and so on, building up a foundation that could be several feet thick. Standing on this mattress, builders could then force sharpened posts down into the yielding mud below, but only far enough to make them stand upright. Push too far, and they disappear into the bottomless muck forever. The shelter itself was built on a platform above this foundation, using a series of arches similar to Iroquois longhouse construction. The uprights on both sides had their ends bent over and lashed together, forming curved ribs that could flex with wind and weather without breaking. Over these arches, horizontal poles were lashed to create a framework that could be thatched with whatever materials were available. But the Bog Ken had features that went beyond basic shelter. Tin pans with holes in the bottom were slid over the supporting poles to prevent varmints, rats, snakes, and other creatures from climbing up into the living space. The elevated position also provided natural protection from mosquitoes, which clung to the marsh grass below and rarely rose above it except in completely still air. The floor was made from halved logs, carefully fitted and covered with browse, hay, or rushes for comfort. A fireplace could be built by enclosing a bed of mud between 4 logs, creating a safe cooking and heating area that wouldn't ignite the structure. The Bog Ken is one that is built over boggy or marshy places too soft to support an ordinary structure. This wasn't just a shelter, it was a complete survival system that allowed people to live safely in terrain that would otherwise be uninhabitable. The Bog Ken proved that with the right knowledge, even the most hostile environments could be conquered. If you want to learn more about traditional survival techniques that conquered impossible terrain, check out our episode on 28 forgotten survival tricks that could save your life in the wild. Number 4. The fallen tree shelter. When darkness was falling and a man had nothing but the clothes on his back and maybe a knife, the fallen tree shelter could mean the difference between surviving the night and becoming another casualty of the wilderness. This technique was the ultimate emergency shelter, fast, effective, and requiring nothing more than what nature provided and a man's ability to recognize opportunity. The method was brutally simple, but required precise execution. The survivor would select a thick-foliaged fir tree, preferably one with dense branches that reached nearly to the ground. Using whatever cutting tool was available, a knife, hatchet, or even a sharp stone, he would cut partially through the trunk, just enough to weaken it so that it would fall in a controlled direction. The key was the partial cut. Too little, and the tree wouldn't fall. Too much, and it would crash unpredictably, potentially injuring the builder or destroying the very branches that would provide shelter. Once the tree was down, the real work began. The branches on the underside, the side that would become the floor, were trimmed away to create a space large enough for a man to lie down. This wasn't just clearing space, it was creating a natural mattress from the smaller branches and needles that were removed. The larger branches that remained formed the walls and partial roof of the shelter. The genius was in the next step, using the tree's own branches to complete the roof. The branches that had been trimmed from the top side of the fallen trunk were carefully arranged over the shelter, with their butt ends pointing upward and their tips pointing down toward the ground. This arrangement was critical. It created a natural shingling effect that would shed rain and snow rather than collecting it. The final layer was smaller browse, pine needles, small twigs, and any available vegetation, thatched over the larger branches to fill gaps and create a weatherproof barrier. When properly constructed, this shelter could keep a man dry and protected from wind in conditions that would otherwise be fatal. The fallen tree shelter worked because it solved multiple survival problems simultaneously. It provided immediate protection from the elements, created an insulated sleeping area using the tree's own needles and branches, and could be built in under an hour by a single person with minimal tools. The thick foliage of a properly selected tree could provide insulation equivalent to several blankets, while the natural oils in pine and fir needles helped repel insects. For a one-man, one-night stand, select a thick foliaged fir tree and cut it partly through the trunk so that it will fall. Then trim off the branches on the underside so as to leave room to make your bed beneath the branches. This wasn't a long-term solution. It was an emergency technique that could save a life when time was running out and options were few. In the hands of someone who understood the method, a single tree could become a complete survival shelter in the time it took the sun to set. Number 5. The Navajo Hogan. In the harsh deserts and mountains of the American Southwest, where temperatures could swing from scorching heat to deadly cold in a single day, the Navajo people perfected a shelter design that was both simple to build and incredibly effective: the Hogan. This wasn't just a house, it was a survival structure that could be adapted to virtually any environment and built with whatever materials the land provided. The traditional survival Hogan was a 6-sided dome structure that combined the stability of a log cabin with the strength of an arch. Construction began by laying out 6 walls in a hexagonal pattern, using the same notching techniques that would later be adopted by European settlers for their log cabins. But instead of building straight up, the Hogan builders angled each successive layer of logs inward, creating a dome shape that grew stronger as it rose. The engineering was sophisticated despite its apparent simplicity. Each log was carefully notched to fit snugly against its neighbors, creating joints that locked together under the weight of the structure above. As the walls curved inward, the logs became shorter, until finally the dome was completed with a small opening at the top for smoke to escape. This opening wasn't just functional, it was precisely sized to create proper ventilation while minimizing heat loss. The dome shape was critical to the Hogan's effectiveness. Unlike flat-roofed structures that could collapse under heavy snow loads or peaked roofs that created wind resistance, the curved dome distributed weight evenly and deflected wind from any direction. The structure was so stable that it could withstand the severe windstorms that regularly swept across the Southwest, storms that could destroy conventional buildings. But the real genius of the Hogan was its adaptability. In hot climates, the structure could be left uncovered or covered with brush to provide shade while allowing air circulation. In cold climates, the same basic structure could be covered with earth, sod, or thick layers of bark to create insulation that would maintain comfortable temperatures even in freezing weather. The central fire pit provided heat that was efficiently distributed throughout the dome-shaped interior. The entrance was another carefully engineered feature. Instead of a simple doorway, the Hogan featured a covered entrance passage that prevented direct wind and rain from entering the living space. This entrance could be extended into a full shed-like structure for additional protection in severe weather. The Navajo Hogan proved that effective shelter design wasn't about complexity. It was about understanding the fundamental principles of structural engineering and environmental adaptation. A properly built Hogan could house a family through multiple seasons, providing protection that was superior to many modern structures, while using only materials that could be gathered from the immediate environment. This one is six-sided and may be improved by notching the logs and building them up one on top of the other, dome-shaped to the required height. The Hogan represented thousands of years of refinement in shelter design, a structure so perfectly adapted to its environment that it remained virtually unchanged for centuries because it simply couldn't be improved upon. Number 6. The Scoutmaster Shelter. When a man found himself in the wilderness with no rope, no nails, and no complex tools, the Scoutmaster Shelter offered a solution that seemed to defy logic. A stable, weatherproof structure built from nothing but 3 forked sticks and whatever natural materials could be gathered in an hour. This technique represented the pinnacle of primitive engineering, maximum shelter with minimum resources. The foundation of the Scoutmaster Shelter was a tripod formed by 3 carefully selected forked sticks. But this wasn't random construction. The forks had to be precisely matched and interlocked in a specific way to create a self-supporting structure. The 3 forked ends were interlocked so that each fork held the other 2 in place, creating a joint that actually grew stronger under load. This interlocking system meant that the entire structure was held together by its own weight and the natural tension of the wood. The selection of the forked sticks was critical. They had to be strong enough to support the weight of the covering materials, flexible enough to bend slightly without breaking, and shaped so that the forks would interlock properly. Experienced builders could identify the right sticks at a glance, looking for specific angles in the forks and particular grain patterns in the wood that indicated strength and flexibility. Once the tripod was established, the framework was completed by resting additional poles against the 3 main supports, their butts forming a circle on the ground. These poles didn't need to be attached. They were held in place by gravity and the angle of their placement. The result was a cone-shaped framework that could support considerable weight while remaining flexible enough to move with wind and weather. The covering technique was where the real skill showed. Branches were placed with their butt ends pointing upward, creating a natural shingling effect that would shed water rather than collecting it. This wasn't intuitive. Most people would naturally place branches with their tips up, the way they grow. But the Scoutmaster technique reversed this, using the natural curve of the branches to create a surface that directed water away from the shelter. The final layer was smaller browse, pine needles, leaves, or any available vegetation, thatched over the larger branches to fill gaps and create a weatherproof barrier. When properly constructed, this shelter could keep multiple people dry and protected from wind in conditions that would make camping impossible. The Scoutmaster Shelter could be scaled from a one-man emergency refuge to a structure large enough for several people. The same basic technique worked regardless of size, making it one of the most versatile survival shelters ever developed. It could be built in forest, prairie, or mountain environments using whatever materials were locally available. For more details on frontier construction methods that used nothing but natural materials, see our comprehensive guide, How Mountain Men Built Cabins, from Scratch, 1.5-hour compilation. Take 3 forked sticks and interlock the forked ends so that they will stand. Over this framework, rest branches with the butt ends up. The Scoutmaster shelter proved that sophisticated engineering didn't require sophisticated tools. It required sophisticated understanding of how natural materials could be combined to create structures that were stronger than the sum of their parts. Number 7. The Log Dugout. When the weather turned truly deadly, when tornadoes, blizzards, or extreme cold threatened to kill anyone caught above ground, early American settlers had one final refuge that could withstand conditions that would destroy any surface structure: the log dugout. This hybrid shelter combined the protection of an underground bunker with the structural strength of log construction, creating a refuge that could keep families alive through the worst disasters nature could deliver. The log dugout was built by excavating a rectangular pit into a hillside or bank, then constructing log cabin walls within the excavated space. This wasn't simple digging. The excavation had to be precisely sized and shaped to accommodate the log walls while providing proper drainage and structural support. The builders had to understand soil composition, water flow, and structural engineering to create a dugout that wouldn't collapse or flood. The log walls were built using the same notching techniques used in surface cabins, but with critical modifications for underground construction. Each log had to be carefully fitted, not just to the logs above and below it, but also to the earth walls of the excavation. The joints had to be tight enough to prevent soil from infiltrating the living space, while still allowing for the natural settling that occurred as the structure aged. The roof was the most critical element. Unlike surface structures that could use peaked roofs to shed water, the dugout required a flat roof that could support the weight of earth covering while still providing adequate protection from the elements. The roof was constructed from heavy logs laid close together, often with a larger log pegged to the rafters above the eaves to hold the sod covering in place. The earth covering wasn't just piled on randomly, it was carefully layered to create insulation and waterproofing. The first layer was often bark or other waterproof material, followed by progressively finer layers of soil, and finally sod with living grass that would grow and create a natural waterproof membrane. When properly constructed, the roof covering could be several feet thick, providing insulation that would maintain comfortable temperatures even in extreme cold. Ventilation was achieved through carefully placed openings that allowed air circulation while preventing heat loss. The entrance was often built as a separate structure or tunnel that prevented cold air from entering the main living space directly. Some dugouts featured multiple rooms connected by tunnels, creating underground complexes that could house extended families. The log dugout was so effective that it became the preferred shelter in areas prone to severe weather. Tornado Alley settlers built them as storm shelters that could withstand winds that would level surface buildings. Arctic explorers used similar techniques to create winter quarters that could maintain livable temperatures when surface temperatures dropped to lethal levels. The dugout represented the ultimate in survival architecture, a shelter that could protect human life in conditions where exposure meant certain death. It proved that when survival was at stake, the combination of underground protection and solid construction could create refuges that were virtually indestructible. To explore more about surviving harsh winter conditions with traditional techniques, check out How Frontiersmen Survived the Frozen Wilderness, 2-hour winter documentary. No heating bills, no grocery stores, no emergency services. Out there on the frontier, winter wasn't just cold, it was a 6-month death sentence for families who weren't prepared. The temperature could drop to 40 below zero. Snow could pile 15 feet deep. Blizzards could last for weeks without stopping. They needed skills that could keep a family alive when the world turned into a frozen wasteland. They needed techniques that worked when modern conveniences didn't exist. They needed knowledge that meant the difference between survival and becoming another family that simply vanished when spring arrived. Every skill mattered. One forgotten technique, one failed preparation, and an entire family could freeze, starve, or disappear forever into the endless white. The families who survived multiple frontier winters knew secrets that have been lost to modern comfort, skills that were passed down through generations of life and death experience. But which winter survival skills were absolutely essential for frontier family survival? How did these families maintain heat, food, and sanity during months of brutal isolation? And which forgotten techniques could still save lives in modern winter emergencies? Today, we're exploring the winter survival skills that kept frontier families alive when death was just one mistake away. My name is Sam, and this is Wild America. Between 1800 and 1890, winter killed more frontier families than disease, accidents, and hostile encounters combined. The families who survived weren't just lucky. They possessed specific skills that had been refined through generations of trial and error. These weren't the basic winter tips found in modern survival guides. These were life-or-death techniques that worked when everything else failed. 1. The heat banking system. Frontier families couldn't afford to waste a single BTU of heat energy. They developed a sophisticated heat banking system that captured, stored, and redistributed warmth throughout their homes with remarkable efficiency. This wasn't just about building fires, it was about creating a thermal management system that could keep a family alive for months. The foundation was the thermal mass principle. Frontier families would heat large stones, bricks, or metal objects in their fires, then strategically place them throughout the cabin to radiate heat for hours. But the key was understanding which materials held heat longest and how to position them for maximum effectiveness. They learned to create heat circulation systems using the natural convection currents in their cabins. By positioning furniture, hanging blankets, and creating air channels, they could direct warm air to sleeping areas and cold air back to the fire. This created a continuous circulation that maximized heat distribution. The bed warming technique was crucial for survival. Families would heat stones or metal objects, wrap them in cloth, and place them in beds before sleeping. But they had to understand the exact temperature that provided warmth without causing burns and how to maintain safe heat levels throughout the night. They also developed heat recovery systems that captured waste heat from cooking, washing, and other activities. Every source of warmth was channeled into the overall heating system, creating efficiency that modern homes rarely achieve. The timing was critical. Frontier families knew exactly when to bank heat, when to let fires burn down, and when to restart heating cycles. This knowledge required understanding weather patterns, indoor temperature fluctuations, and fuel consumption rates. This system allowed families to maintain livable temperatures using minimal fuel during the harshest winter conditions. The knowledge was passed down through practical experience, with each generation adding refinements that improved efficiency and safety. 2. The Food Preservation Network. Keeping food fresh during winter months without refrigeration required a complex preservation network that went far beyond simple root cellars. Frontier families developed multiple preservation methods that ensured adequate nutrition throughout the winter while preventing spoilage and food poisoning. The cold storage system utilized natural refrigeration in sophisticated ways. Families knew how to create multiple temperature zones around their property, from freezing areas for meat storage to cool areas for vegetables. They understood how to maintain consistent temperatures and prevent freeze-thaw cycles that would spoil food. The smoking and curing techniques were incredibly advanced. Different meats required different smoking methods, salt concentrations, and curing times. Families knew how to process everything from large game to small birds, creating preserved meats that would last for months without spoiling. The fermentation processes provided essential nutrition during winter months. Families would ferment vegetables, dairy products, and even some meats to create foods that were not only preserved but actually improved in nutritional value. This knowledge required understanding bacterial cultures, pH levels, and fermentation timing. The fat preservation system was crucial for winter nutrition. Families knew how to render, store, and use animal fats that provided essential calories and vitamins during cold months. They understood which fats stored best, how to prevent rancidity, and how to incorporate fats into winter meals. The seed and grain storage required protecting food supplies from rodents, moisture, and insects while maintaining nutritional value. Families developed container systems, pest control methods, and storage environments that kept grains fresh for months. The rationing system ensured that food supplies lasted through unpredictable winter lengths. Families had to calculate consumption rates, plan for extended winters, and adjust portions based on available supplies and family needs. This preservation network provided the nutritional foundation that allowed families to survive winter months when fresh food was impossible to obtain. The techniques required years to master and were essential for frontier survival. 3. The Water Security Protocol. Maintaining access to clean water during winter was a life-or-death challenge that required multiple backup systems and sophisticated techniques. Frontier families couldn't simply turn on a tap. They had to ensure water access when sources froze, became contaminated, or were buried under snow. The well protection system prevented water sources from freezing solid. Families knew how to insulate wells, create circulation systems, and maintain access even in extreme cold. They understood how to break ice safely and how to prevent well contamination during winter months. The snow melting techniques provided emergency water when other sources failed. But families had to understand which snow was safe to melt, how to purify melted snow, and how to melt large quantities efficiently without wasting fuel. They knew that fresh snow, old snow, and ice required different treatment methods. The water storage system ensured adequate supplies during blizzards or when sources became inaccessible. Families maintained multiple storage containers, understood how to prevent stored water from freezing, and knew how to rotate supplies to maintain freshness. The purification methods were essential when water sources became contaminated or questionable. Families knew how to use natural filtration materials, boiling techniques, and chemical treatments that made questionable water safe to drink. The ice harvesting provided long-term water storage using natural freezing. Families knew how to cut, transport, and store ice that would provide clean water throughout the winter. This required understanding ice quality, storage methods, and preservation techniques. The conservation techniques maximized water usage when supplies were limited. Families knew how to reuse water for multiple purposes, how to minimize waste, and how to stretch limited supplies during emergencies. This water security protocol ensured that families had access to clean water regardless of weather conditions or source availability. The knowledge was essential for winter survival and required understanding hydrology, chemistry, and resource management. 4th, the clothing and insulation system. Staying warm in frontier winters required a sophisticated clothing and insulation system that went far beyond simply wearing more layers. Families had to create, maintain, and optimize clothing systems that could keep them alive in deadly cold while allowing them to work and function normally. The layering principle was incredibly advanced. Families understood how to create air gaps between clothing layers, how to manage moisture and ventilation, and how to adjust layers based on activity levels and temperature changes. They knew which materials worked best for base layers, insulation layers, and outer protection. The material selection required understanding the properties of different fabrics, furs, and natural materials. Families knew which materials provided the best insulation, which were most durable, and which could be maintained and repaired in frontier conditions. They understood how to combine materials for maximum effectiveness. The construction techniques created clothing that was both warm and functional. Families knew how to sew, fit, and design clothing that allowed for movement while providing maximum insulation. They understood how to create wind-resistant outer layers and moisture-wicking inner layers. The maintenance system kept clothing functional throughout the winter. Families knew how to clean, repair, and waterproof clothing using available materials. They understood how to prevent clothing damage and how to extend the life of essential garments. The footwear system was crucial for winter survival. Families knew how to create, maintain, and waterproof boots that could keep feet warm and dry in snow and ice. They understood how to prevent frostbite while maintaining mobility and function. The bedding system provided warmth during the coldest nights. Families knew how to create, layer, and maintain bedding that could keep them warm when cabin temperatures dropped below freezing. They understood how to share body heat effectively and how to prevent heat loss during sleep. This clothing and insulation system was the first line of defense against winter cold. The knowledge required understanding materials, science, human physiology, and practical construction techniques that were essential for survival. 5. The emergency fuel management. Maintaining adequate fuel supplies during winter was a complex logistical challenge that required planning, conservation, and emergency protocols. Frontier families couldn't simply order more fuel. They had to manage limited supplies that meant the difference between life and death. The wood selection system maximized heat output from available timber. Families knew which tree species burned hottest, which provided longest burn times, and which were best for different heating needs. They understood how to identify, harvest, and prepare different types of wood for optimal burning. The cutting and splitting techniques prepared fuel efficiently while conserving energy. Families knew how to process large amounts of wood quickly, how to split wood in freezing conditions, and how to create different sizes for different burning needs. They understood how to maintain tools and work safely in winter conditions. The storage system protected fuel supplies from moisture and made them easily accessible during storms. Families knew how to stack, cover, and organize wood supplies that would remain dry and usable throughout the winter. They understood how to calculate fuel needs and how to ration supplies. The burning optimization techniques maximized heat output while minimizing fuel consumption. Families knew how to build fires that burned efficiently, how to control airflow for optimal combustion, and how to maintain fires for extended periods with minimal fuel. The alternative fuel sources provided backup when wood supplies ran low. Families knew how to use corn cobs, dried grass, animal dung, and other materials for emergency fuel. They understood how to prepare and burn alternative fuels safely and effectively. The conservation methods stretched limited fuel supplies during emergencies. Families knew how to reduce heating needs, how to concentrate heat in essential areas, and how to maintain minimal heat levels that prevented death while conserving fuel. This fuel management system ensured that families could maintain life-sustaining heat throughout the winter regardless of supply challenges or unexpected emergencies. The knowledge required understanding combustion, resource management, and emergency planning. 6. The medical emergency protocol. Winter medical emergencies were often fatal because professional help was impossible to reach. Frontier families had to develop comprehensive medical protocols that could handle everything from minor injuries to life-threatening conditions using only available resources. The frostbite treatment system could save fingers, toes, and lives when exposure occurred. Families knew how to recognize different stages of frostbite, how to rewarm affected areas safely, and how to prevent infection and complications. They understood which treatments worked and which could cause additional damage. The hypothermia revival techniques could bring family members back from near-death cold exposure. Families knew how to rewarm hypothermia victims gradually, how to maintain vital functions during treatment, and how to prevent dangerous complications during recovery. The respiratory illness management was crucial when pneumonia and other winter diseases struck. Families knew how to create steam treatments, how to use natural expectorants, and how to maintain breathing function when medical help was unavailable. They understood how to prevent respiratory infections from becoming fatal. The injury treatment protocols handled cuts, burns, and broken bones that occurred during winter work. Families knew how to clean and dress wounds in unsanitary conditions, how to set bones and create splints, and how to manage pain using natural materials. The childbirth procedures ensured safe delivery when babies arrived during winter months. Families knew how to assist with difficult births, how to care for newborns in cold conditions, and how to handle complications that could kill both mother and child. The mental health management addressed the psychological challenges of winter isolation. Families knew how to recognize and treat depression, anxiety, and cabin fever that could lead to dangerous behavior or suicide during long winter months. This medical protocol provided the healthcare foundation that kept families alive when professional medical help was impossible to reach. The knowledge required understanding anatomy, physiology, and practical medicine that was essential for frontier survival. 7. The communication and rescue system. Maintaining contact with the outside world and ensuring rescue capability during winter emergencies required sophisticated communication and signaling systems. Frontier families couldn't rely on modern communication. They had to create their own networks and emergency protocols. The signal fire system could summon help from miles away when emergencies occurred. Families knew how to create smoke signals that could be seen from great distances, how to maintain signal fires in winter conditions, and how to communicate specific messages using smoke patterns and timing. The trail marking techniques ensured that rescue parties could find isolated cabins even in heavy snow. Families knew how to create permanent markers that remained visible in winter, how to maintain trail systems, and how to guide rescuers to their location during emergencies. The neighbor network provided mutual aid and emergency support during winter months. Families established communication schedules, check-in procedures, and mutual assistance agreements that ensured help would come when needed. They understood how to coordinate resources and share emergency supplies. The weather monitoring system predicted dangerous conditions that required emergency preparations. Families knew how to read natural weather signs, how to prepare for severe storms, and how to communicate weather warnings to neighbors and travelers. The emergency supply caches provided resources for rescue operations and extended emergencies. Families maintained hidden supply depots that could support rescue parties or provide emergency resources when primary supplies were exhausted. The evacuation procedures ensured family survival when cabins became uninhabitable. Families knew how to abandon their homes safely, how to travel in winter conditions, and how to reach emergency shelter when their primary residence failed. This communication and rescue system provided the safety net that could save families when individual survival efforts failed. The knowledge required understanding logistics, communication, and emergency planning that was essential for frontier winter survival. These 7 winter survival skills represented the difference between life and death for frontier families. Each skill required years to master and was essential for surviving the brutal winters that claimed so many lives. In our modern world of central heating and emergency services, these techniques remind us of the incredible knowledge and resilience required to survive when comfort and safety were luxuries that didn't exist. My name is Sam, and this is Wild America.